If you want to invest your fund in stocks or in trading or in real estates, then check the links in the description below. Also, don't forget to like, share and subscribe to this channel. In this video, we will see impedance combinations. Example, question, find current I in the circuit of figure. For this circuit, we have to find this current I. As we can see, the values are given in frequency domain format. So it is very easy to find. We can directly find the value of this current I just by dividing voltage by impedance. So first we need to find the value of equivalent impedance or ZEQ or total impedance. So solution, as we can see, this forms a star connection or Y connection. So first we will convert this Y into its equivalent delta. So let's take this much part from here. Let's copy it and paste it here. So here we can write convert Y to delta. Convert Y to delta. So here we can see this is A, this is B and this point is C. And let's say this point is O. So this will be, let's say this is Z1, this is Z2 and this is Z3. So now we have to find AO, then AC and CO. So first we will find ZAO. So ZAO is equal to, this will be Z1 into Z3 into, it will be like this, Z1 into Z3 plus Z3 into Z2, Z3 into Z2, then Z2 into Z1, Z2 into Z1 divided by, we have to divide this by, currently we are finding between this A and this O. So we are finding this value here. It will be something like this. We are finding this value of impedance ZAO. So it will be divided by this 8 ohm, that is Z2. Now let's substitute all these values here. So Z1 value is J4 into Z3 value is minus J3 plus Z3 again minus J3 into Z2 value is 8, then plus Z2 value is again 8 ohm into Z1 value, it is J4 divided by Z2, which is 8 ohm. So this will be the value of ZAO. Now for all the parts of this ZAO, ZOC and ZCA, so the numerator will remain same. So let's simplify this in calculator directly. ZAO will be equal to, we have to take the calculator in complex mode. So this will be I into 4, then into minus I into 3, then plus in bracket minus I into 3 into 8 plus 8 into in bracket I into 4 divided by 8. So it is 1.5 plus j. 1.5 plus j. Since it is impedance, so its unit will be ohm. Then next we have to find this impedance. So it will be ZCO, let's say. So ZCO will be equal to, here we can write ZCO is equal to, again the numerator will remain same. So same formula, just we have to replace the denominator part. The denominator will be for this ZCO. The denominator will be this Z1. So Z1. Again, we can directly copy this part. So let's copy it from here and paste it here. Now the denominator will change to Z1. The value of Z1 is J4. So this will be J4. So ZCO is equal to, just we have to replace the denominator, I into 4. So it is 2 minus 3j. 2 minus 3j. Then next is ZAC. ZAC. We have to find the ZAC. This is ZAC. So ZAC will be equal to, again same formula, just we have to replace the denominator part. We are converting from star connection or Y connection to delta connection. So now the denominator for ZAC will be, the opposite of this is Z3. So here this will be Z3. So ZAC is equal to, again the numerator will be same. The numerator will remain same, but the denominator part will change. It will be Z3, that is minus J3. Minus J3. So therefore ZAC is equal to, just we have to replace the denominator part to minus I into 3. So it is 2.66 minus 2.66 plus 4j plus 4j ohm. Also this is ohm since it is impedance. Now we can easily redraw the circuit and change the star network to delta network. So let's copy this. Now here we can erase this internal star and replace this by its equivalent delta connection. So the equivalent delta will look something like this. So now this will be ZAC. Let's say we are assuming this as O. So this is ZAO and this is ZCO. So let's put all the values of ZAC, ZAO and ZCO. So first let's put the value of ZAO. It is 1.5 plus J. 1.5 plus J. Now the value of ZCO value is 2 minus 3J. So 2 minus 3J. And the value of ZAC is minus 2.66 plus 4J. So now we can easily simplify this. As we can see, these two are in parallel. Also, these two are in parallel and both are in series. So let's simplify the circuit and find the value of ZEQ. So this will be, also let's assume this as, we are assuming this as, let's say this is Z1 and this is Z2 and this is Z3. So now we can easily simplify this. So Z1 is parallel with ZAC. So we can write full ZEQ as ZEQ is equal to Z3 in series with, it is in series with these two parallel resistance. So let's take this in square bracket like this. So here we can write Z1 parallel with ZAC. Then it is in series with Z2 parallel with ZCO. Now they both are parallel with ZAO. So they are both parallel with ZAO. So it will look something like this. Can erase this bigger part. So here we can see again Z3 is in series with Z1 parallel with ZAC. It is in series with Z2 parallel with ZCO. And both are connected in parallel with ZAO. So let's simplify this now. So it will be something like this. Z3 plus, in square bracket, this will be Z1 into ZAC divided by Z1 plus ZAC, then plus Z2 into ZCO divided by Z2 plus ZCO. Then it is parallel with ZAO. So first we will find this value inside the bracket. So let's take this value and we will find this first. So this part will be equal to, let's put all the values of Z1 and ZAC. So Z1 value is 2 minus J4. So let's put it here. 2 minus J4 multiplied with minus 2.66 plus 4J. Minus 2.66 plus J4 or 4J. Now they will be divided by same value but in addition. So again 2 minus J4 plus minus 2.66 plus J4, then plus Now the value of Z2. The value of Z2 is 8 plus J6. 8 plus J6 in one bracket, and in another bracket this will be 2 minus 3J. 2 minus 3J. So this will be divided by same value 8 plus J6 plus 2 minus 3J. So this will be, let's simplify this in calculator directly. So 2 minus I into 4 into minus 2.66 plus 4 into I divided by 2 minus I into 4 plus minus 2.66 plus I into 4, then plus again this part is in bracket 8 plus I into 6 multiplied with 2 minus 3 into I divided by same value 8 plus I into 6, then plus 2 minus 3 into I. So this will be this much value minus 13.39. So let's convert this value into its equivalent polar form. Let's see. First we have to find the value in polar form. We have to find the value in frequency domain. So let's take this value in polar form. So it will be shift 2 and 3. So it is 33.10 at an angle minus 113.86, and since it is impedance, so its unit will be ohm. So we got the value for this part only. Now we will multiply this value with ZAO. So again let's copy this part. Let's put all the values here. Now we can easily substitute the value of Z3. So the value of Z3 is 12. So 12 plus the value of this part is this much. So let's put it there, and we have to multiply it and divide it. We have to do this parallel operation of this value. So this will be 33.10 at an angle minus 113.86. It is multiplied with ZAO. The value of ZAO is 1.5 plus J. 1.5 plus J, then same value divided by 33.10 at an angle minus 113.86 plus 1.5 plus J. So this will be the value of ZEQ. Let's put all the values in calculator. So 12 plus, so here this will be 33.10 at an angle minus 113.86 multiplied with 1.5 plus this I divided by 33.10 at an angle minus 113.86 bracket close plus in bracket 1.5 plus j. We can delete this bracket. So now the answer will be this much, 13.60 plus j 0.999. Now we can easily convert this into its equivalent polar form. So shift to 3. So it is 13.63 at an angle 4.2 degree, and since it is impedance, so its unit will be ohm. So therefore ZEQ is equal to 13.63 at an angle 4.2 degree ohm. But we have to find the value of current I, and we know that current I is equal to V upon ZEQ. Now let's substitute the value of voltage V. It is 50 at an angle 0 degree. 50 at an angle 0 degree divided by this value 13.63 at an angle 4.2. So if we solve this in calculator, so it will be 50 at an angle 0 divided by 13.63 at an angle 4.2. So this will be 3.65, or we can directly get the value in polar form. So shift 2 and 3. So it is 3.66 at an angle minus 4.2, and since it is current, so its unit will be ampere, and here this will be degree. So therefore current I is equal to 3.66 at an angle minus 4.2 degree ampere. So this is the answer for current in phasor domain format or in frequency domain. Don't forget to like, share and subscribe to this channel, and thanks for watching.